About computer languages. So, introduction to computer languages. Programs are written using computer languages. So, every program you are going to write, you should use any language to write the program. For example, C language, C++, Java, so SQL languages. So, any program you are going to write with a language. So, these languages are divided into three categories: machine languages, symbolic assembly languages, high level languages. So, machine language has been introduced in 1940 year, and assembly language were introduced in 1950s. High level languages are introduced in 1960. So, as the evaluation years are going on, as the years are passing away, so they have invented new languages. First, machine language. What is meant by a machine language? Machine language nothing but it understands only zeros and ones. It understands only zeros and ones. Okay, that is nothing but a machine level language. So machine language understands only zeros and ones. It is also called as low level language. So human cannot understand this machine language. Only computer can understand. Computer can understand 100%, whereas user can understand 0%. Okay, so computer specific and directly understand by the hardware. So the zeros and ones are directly understand by the hardware which are there inside the processor. Okay, some hardware devices are there like adder, subtractor, multiplier, okay, na, divider. Some hardware circuits like ALU, arithmetic logic unit. For example, a program which you are writing in any language, so it has to convert finally into the zeros and ones only. Because so whatever program you are writing in high level language, processor does not understand high level language. It understands only zeros and ones. So who is going to convert high level language into machine language? So compilers. Compiler converts high level language into machine level language. So what is the advantage of this machine level language? So faster execution, because so no translation required. If we are writing a program in high level language, so there is a need of translations to convert or compilers to convert high level language into machine level language. Okay, no? So no translations are required. Directly we are going to write a program in zeros and ones. So directly it can understand. Okay. What are the disadvantages? So this machine language is machine dependent. Okay, na? So here I am using a processor here. So this processor you have to write so separate machine language for this, and you are going to use another processor. So you should write another zeros and ones. So depending on the processor, that machine language may vary. So but it is a machine dependent. So we are writing a machine language for one machine. Same machine language in terms of zeros and ones cannot be understood by the another machine. Clear? So difficult to write, debug and understand. So completely user cannot understand this, only machine can understand it. Okay, na? So what are the examples? So for example, I am writing addition of two numbers. So this I am writing a numbers to understand, but so some complex numbers I cannot write this stream of zeros and ones, because two number I am writing 0010. So two is for our understanding, it is not so we should write in terms of zeros and ones. Okay, you are taking a longer number, for example, so 1765. So I cannot write this equivalent of binary value. I need to do some conversions to understand decimal number into binary number. I cannot, because this cannot be understand. 1765 cannot be understand by the processor. So we need to, before we need to write 1765 for example, so we have to convert into the binary first, then you should give the binary number to the processor, then only it understands. Okay, now? So like that, so it understands only zeros and ones. Next, 1950, there was invented assembly language, by using some symbolic representation. For example, so addition, subtraction. So add is an add, nothing but gives information about addition. Move, nothing but move data from one place to, for example, move. So R1 comma R2. The content of R2 is moving to the R1. So like this, some by they are using some assembler codes. These are the codes, assembly codes, okay, which can be understand 50% by the user and 50% by the computer or machine. Okay na? So uses mnemonics add, move, okay na, increment r1, okay na, decrement r2. So like this, so there are a basic, a processor, a machine has 74 opcodes are there, basically 74 opcodes. What is mean by opcode? Nothing but operational code. What is that? Operational code. So for example, I'm writing add a comma b. Example, I'm writing add a comma b. So add is an opcode which informs the processor perform addition operation on the data which is available in the A register and B register. You know, the content of A and B are added. For example, A equal to 10, B equal to 20. After addition of this instruction, okay, na, what is the result? 10 plus 20, nothing but what? 30. So how the processor knows it has to perform the addition? Because I wrote na IDD. By looking into that, processor can understand it has, I have to perform addition operation the value of A plus and value of B. So that is nothing but so assembler, okay na? So we are going to use some opcodes for writing the program, okay na? So introduced by the Grace Hopper, so assembly language, and is easier to understand because it is simple, no? Add a comma b means you can easily understand. Subtract a comma b you can easily understand. So by using some, these are called as a mnemonics or opcodes or assembly codes. Okay, now easier to isolate the errors. You can find the errors and more hardware control advantage. Disadvantage is what it is also machine dependent. Okay, now for example, I am writing a program. So for example, addition by using some operational codes. Okay, now so same codes we cannot use for another machine. It is also machine dependent. For example, I'm writing a I'm writing a program for microprocessor. It is a processor. So same machine opcodes cannot be used for another car processor microcontroller or advanced microprocessors. So same code cannot be used. Some variations will be there. Okay, now so what I meant to say finally, so assembly code are going to use some mnemonics or opcodes, easy to understand and easy to find the errors, and more hardware control is required. And disadvantage is what? The machine dependent. So translators are required because I'm writing add, increment, decrement. So these are cannot be understand by the processor machine. Hence we need to convert this assembly code into machine language, means in terms of zeros and ones, by the assembler. What is that? Assembler converts so assembly language into a machine language. 100% translators are required to convert assembly code into machine code. Okay, so that's why it's a little slower development. Okay, because the conversion from high level language into assembly language into machine language, the conversion takes some time. That's why it is little slower than the machine language. So machine language is a faster because directly I am giving zeros and ones, directly I'm giving, no, so no translations are required. Whatever data we are giving in terms of zeros and ones, machine can easily understand it. Okay, so these are the some assembly language: push, subtract, addition, XOR. These are logical operations: XOR gate, OR gate. So like this I can give some opcodes in assembly language. So these are the, here is some English letters, no? So processor does not understand English letters. We need to convert into the machine code zeros and ones by the assembler. Assembler converts. Okay, na? So assembly code into machine code. So next I'm coming to the high level languages. So focus on solving problems. So we are going to write programming software, not the hardware. So portable across systems. Example, C is a C language, C++, Java. These are the high level languages. And what are advantages? Easy to learn and maintain, mission independent. So far we have discussed machine language and assembler language, these are the machine dependent. Are you getting me or not? But here, so high level language are machine independent. What is that? Independent means, so a program you write it once and you can execute in any machine. I'm writing a program once in one machine. Same program you can execute in another machines also. That is called machine independent. It's a portable. It can run on any operating system. I'm writing a program. For example, my laptop has Windows 10. Windows 10 operating system. So same program I can execute in Windows 12, Windows 8, Windows 7. So in independent of the operating system, I can run my program. That is called portable. Okay na? So better readability, we can easily understand. Okay, for example, I'm writing a program as, for example, I'm writing a C program as include stdio dot h. Okay, I'm writing void main. So I'm declaring int a equal to 10, right? Int b equal to 20, then int c equal to a plus b. Okay, then printf percentage d comma, so my answer is c, no. So I can write like this. So this is nothing but a high level C program. So each instruction can be understand very easy compared to the assembly language as well as machine level language. But what's the disadvantage? Need translation, because so C language, just now I wrote program in C language. So in order to convert it, that is high level language, I have written in high level language. But in order to convert high level language into machine language, I should use the compiler. Compiler converts high level language, high level C language into machine understandable language. So compilers are required. Okay, so that's way. So where there is a need of translation, so the translation takes more time to convert high level language into machine level language. Slower execution, less hardware control, because we are going to interact with the program only, not the hardware directly. But in the previous case, machine level language, assembly language, we need to interact with the hardware by giving information in terms of zeros and ones as well as assembly codes. So this is high level language. I written void main int a comma b comma c. So this is a high level language. So we read a compiler to convert high level language into machine level language. So finally, so computer language are comparison table. Okay, now first machine dependent. Okay, now so because machine language is machine dependent, assembly language is also machine dependent, but C language, high level language, machine independent. And you can write normal English. So like int a comma b, int I wrote int a equal 10, int b equal to 20. Translation not needed here because already we are writing in the form of zeros and ones. But here needed translator. Assembler convert high level language into machine level language, and here compilers required for C language and C++, nothing but, and Java. So Python. So compilers, interpreters, cross compilers which converts high level language into machine understandable language. Finally, what did you understand? You can write any high level language, but finally that will be converted into machine level language only. Are you getting me or not? So that once you convert into the machine level language, then only machine can understand. Otherwise, machine cannot understand. So language only one per machine. So manufacturer specific and many available. So many languages are available here. But machine language is only one. Nature difficult, and difficult it is easy to understand. Memory space less. So machine language takes very less amount of memory, and assembler has very less amount of memory, whereas high level language takes little more memory to store our program. Okay, na? So these are language translators. Compiler converts high level language into machine code. Assembler assembly into machine code. Interpreter line by line translation and execution. In the case of Python, the program will be compiled line by line. Each line can be compiled. But in C program, after writing the complete program, so total program will be compiled or converted at a time from high level language into machine level language. But whereas Python, so once you writing one instruction, for example, print 10 plus 20, immediately this will compile and execute it. Need not write all the complete program at a time. But in C language, so total program will be compiled at a time, then executed. In Python, line by line compilation and line by line execution is done. Okay na? So this is compiler versus interpreter. So execution faster and interpreter slower. So output object code file and no permanent output. Usage, so compilers are widely used and interpreters are limited access. Okay. Thank you for watching my video.